I am Dr. Victor Rivera Monroy, an associate professor in the Department of Oceanography and Coastal Sciences at Louisiana State University, and I am a coastal and wetland ecologist. I also work with the South Central Climate Science Center. In this video, I will discuss how we manage the various impacts of climate change of coastal systems. We know that humans are altering our global climate at rates that are rapid compared to the historical and recent geological record. And yet, we are just starting to define and quantify the large range of impacts and interactions that result from co-occurring climate, CO2, and non-climate stressors. In many cases, existing data records are too short to clearly attribute the mechanisms causing observed biological changes in coastal regions, or to differentiate between the effects of natural climate variability and long-term climate trends. Yet, researchers are beginning to find more cases where the relationship between biological change and long-term climate change is clear-cut. For example, we are now seeing the expansion of mangrove wetlands from subtropical coastal regions like Florida to the more temperate climates typical of Louisiana and Texas and the Gulf of Mexico. Mangrove wetlands are composed of mainly salt-tolerant trees and some flowering plants growing in the intertidal zone of tropical and subtropical shores. In comparison, marshes are mainly grasses growing in temperate latitudes when they are well adapted to survive through cold snaps. Mangrove trees can die if cold events where the air temperature is less than -4 degrees centigrade for several days are frequent. Research now shows that with increasing air temperature and less frequent cold snaps due to climate change, mangrove wetlands can thrive and expand northward into temperate regions and change the diversity and productivity of coastal systems previously dominated by marshes. These changes leave land managers with many looming questions about the future of the resources that they manage. Is it better to try to preserve the historical ecosystems of the region or work to support the ecosystems that will thrive under future climate conditions? We need to manage human activities to minimize the impacts of climate change on our coastal regions around the world. Policies that help us manage coastal ecosystems must recognize that there are multiple scales of climate drivers and responses. They also must recognize that pulses of materials, such as fresh water and sediments, and pulses of energy, such as strong storms, are both natural and necessary to sustain coastal ecosystems. However, we also know that such pulses can negatively impact humans. A startling contradiction is that coastal ecosystems provide goods and services that are prized by the public, but are sustained by events such as river floods, which negatively affect human activities and infrastructure. We need to balance the pulses that promote these ecosystem goods and services while protecting humans, their structures, and their activities. For example, we can manage sediment freshwater and nutrient supplies at the regional level by promoting sediment deposition in coastal wetlands using river systems. Enhanced deposition will not only help to counteract sea level rise, but will promote productivity in these valuable wetlands. However, these freshwater and sediment diversion management strategies will require us to remove many of the barriers that currently force the freshwater and sediment directly out to the sea. These barriers to natural deposition are commonplace in coastal Louisiana along the Gulf of Mexico. This region is often considered the poster child of wetland loss in delta systems around the world, as it has lost almost 5,000 square kilometers of the state's land. This loss equates to the disappearance of a football field-sized area of wetlands every 30 minutes. This wetland loss is directly caused by historical hydrological changes to promote navigation and flood protection along the Mississippi River Basin and within cities, including New Orleans. In 2005, Hurricanes Katrina and Rita devastated this city and demonstrated how the interaction of human infrastructure and storms could threaten the sustainability of large cities in the next 50 years. Damage costs of Hurricane Katrina alone were estimated to be around $100 billion. The economic impact underscores how vulnerable coastal regions can be to to climate impacts in the next decade. To mitigate some of these impacts, this region is now the site of the largest coastal restoration project in the U.S. The goal of the project is to reduce land loss, but at an estimated cost of $100 billion over the next 50 years. You may have here the pleas of Pacific Island nations, such as the Marshall Islands, Kiribati, or Tuvalu, that they are being threatened by increasing sea level rise. The encroaching waters will be forcing entire communities to migrate to mainlands, thus disrupting complex social, economic, and cultural networks. In the U.S., this scenario is now a reality. In coastal Louisiana, in the spring of 2016, the entire community of the Isle of John Charles was officially resettled inland with the help of $52 million in federal funding. The island has lost 98% of its land in the last 60 years due to sea level rise and subsidence. For over 170 years, the Biloxi Chitimacha Choctaw Band called this island home. But this environmental degradation has eroded away their homes and all but eliminated the traditional fishing and subsistence farming ways that they follow in the past. In fact, it is estimated that if the Earth's temperature increased by about 7 degrees Fahrenheit, as many as 760 million people around the globe could lose their homes to the ocean. The future of climate change is now here. These communities are currently living climate change impacts that are projected to expand to other regions throughout this century. Given the complexity of the problem and the multiple scales of human impacts, we need to enact multiple management strategies to face the realities of climate change. And as demonstrated by the ongoing negotiations on climate change amongst nations, the solution to controlling greenhouse emissions requires both national and multinational efforts with consequences that go far beyond coastal regions around the world.